Hi guys, welcome to the 90th lecture of the course Biological Diversity Theory, Measure and Data Sampling Techniques. Today I'm going to explain you how to compare communities' diversity. To be able to compare community, we first need to understand what to count as an abundance. Because we can count different things. For instance, we can count the number of individuals, but in some cases when, for instance, we have trees and spruce from trees, it's very difficult to understand what is an individual and what is the different individuals. So in that case we can count, for instance, modular units or densities instead of individuals, or biomass, or for instance percentage of coverage. We can use squares, we can use different sampling techniques. In any case, we need a surrogate of the abundance to account for the differences in biodiversity between different samples. Which methods we have to compare communities? One of these is the rank abundance plot. As I show you, the rank abundance plot is very interesting because you can use two different curves to understand which one is richer, which one has more species, which one is even. The Kolmogorov-Smirnov test is another way to have a statistically reliable method to understand the difference, so if the difference is statistically relevant or not. Richness estimators are also useful, for instance Chow-1, Alpha Fisher, Jackknife, because they estimate the effective number of species and are very useful to understand which community is richer than the other one. Another way is to use the species area curve as a accumulation curve or a rarefaction curve to understand the differences in community. Or we can use the species abundance distribution and calculate the Alpha Fisher. We could have three different scenarios. The first one is that we have areas of the same dimension sampled from similar, ecologically mean communities. The second one is that we have areas of different dimension or samples from different ecologically community. The third different scenario is that we can have a small dimension samples, that is a scenario very often, and we have number of individuals that is minor than 100 or 200. In the first scenario, again, the areas of the same dimension sampled from similar ecological communities, we can use richness and abundance, such as S or N, to compare two communities. A very useful index to compare evenness of the two samples is the EH, and the slope of a ACDF graph as the intercept if N of each sample is measured than 100 individuals. And if we want to understand differences in dominance and rarity, we can just use the relative dominance and the percentage of rare number of individuals divided by number of species, so PCT rare N divided by S. For the second scenario, so if we have areas of different dimension or samples from different ecologically communities, we can use to estimate differences in the richness and abundance the Margalef index or the alpha index if N of each sample is measured than 100, or the Smith-Wilson index to compare abundances. If we want to understand the differences in the evenness, we can use evenness of Shannon or the M of the ACDF, so the slope. And to understand the differences in dominance or rarity, we can use absolute or relative dominance and the percentage of rare at 1 or 5%. In the third case, where the samples are of small dimension, means that the number of individuals are less than 100 or 200, we can use to evaluate the differences in diversity between the two samples the Hilbert-Simpson index, that is very reliable in case of small dimension samples, and we can use 1 minus D, so 1 minus the normal Simpson index. To evaluate the differences in evenness instead, we can just use this Shannon evenness. For the evaluation of dominance and rarity, relative dominance or McNaughton index is very useful, and for rare species the PCT rare to 5% or the PCT rare N divided by S are very useful indicators. Moreover, we can use statistical tests to understand if these differences between communities are more or less statistically evident. And one of these is the t-test or the ANOVA test to compare two or more communities in case of normality of data distribution. If normality cannot be ensured, we can use the jackknifing process. To use the jackknifing process is very simple. We need just to calculate diversity. The Shannon or Simpson is not very important. We can use one of these two. And of all n samples together to obtain a kind of ST, so the original diversity estimation. Then we calculate n times the diversity, excluding each time only one sample to obtain ST minus 1 or minus j. Then we calculate the pseudo values for each n samples, that is just nst minus n minus 1 of sti, that the oj depends on our sample. So we remove from the original diversity estimation the diversity of each sample removed, and we estimate the diversity jackknifing as the sum of these pseudo values divided by n, that is the total number of samples. In this way we can also calculate a standard error, that is simple, the standard error of the estimation of jackknifing process, and we have a very reliable statistics to provide information about the evidence in differences in statistical communities. So in this lecture I try to show you how to compare different communities based on richness and abundance, based on evenness, based on dominance or rarity, and I hope you will use these tools to compare your data and evaluate difference in your biodiversity data. See you next time.